Hey guys, this is AK here. Gonna show you guys quickly how to parameterize a component. Uh, so we're just gonna assume that you have a workspace with a working substrate file, and like if you did assignment 1's transmission line question, then you should be good. I'm working in the same workspace as you can see. So we're just going to start with the layout file. The first thing you want to do is name it something. In my case, we're going to call it test4 because we have too many test files. And scroll down here, zoom in a bit. I have a 1 micron by 1 micron grid. You can change it to whatever you like, doesn't matter. So we're just going to draw a polygon, for example, like a square. And 2 by 2, like there. Oops, made a mistake. It's supposed to be metal layer 1. Alright, there we go, it's red. Then add a port, for example, on each side. And now comes the fun part, parameterizing it. So the way you do it is you select EM, you select component, and then you select parameters. Okay, now the way I like to do it, as I posted a link before, there are 3 ways of doing it. We're going to do nominal and precipitate. Reason being is you can have like any polygon shape, like a cross, and then you can adjust like width, length, and a lot of things. It's also time consuming as well. But anyway, so we're going to increase the length of the transmission line, so we're going to call it an L. Nominal value is 2 because that's the size we're starting with, and let's say we want to go in increments of 1 micron. Okay, now the important thing is you have to select edit and view perturbation. This is where the fun part begins. Sorry. So we are back to the square. What you're doing here is selecting vertices, and this is like a vertex. You have 1 year, you have 1 year, you have 1 year, 1 year, and you can also move the ports. So vertices and ports, you can move them in the x direction, y direction, by a certain value, and that's how you parameterize your component. So we're just going to move in the X. We want to make it longer, a longer transmission line. So let's say we select 1 for now, and you can select 0 because we're not changing the Y, and you have to make sure you select the right vertex when you before you select apply. Okay, so this is the one we want to increase, so you have to select apply, and you see now it's all weird, like it didn't do the other one. So each vertex has to be done separately, and you have to maintain symmetry if you want. And also very important, make sure you move the port, otherwise it's going to give you incorrect results. So vertex 1 is done, the port is the next, now it's again in line, by one micron, and then you have to do the last vertex and then select apply again, and there you go. Made it longer. That's just how you parameterize it. Now you select OK, and you see now you have one parameter in the L direction, for example, and then you select OK. That's it. Now you can see also that it's gone back to its original square, which is good because it's only going to do that once it's doing co-simulations or simulations as a whole. Otherwise it's your original shape that you have. The sad thing is it doesn't show you which are the vertices that you changed, and like how to know which one you did. So it's very important you do that particular step carefully every single time. Alright, we're going to select EM simulation, make sure there's no yellow triangles, so that's good. And the next step is to create the model and symbol. So go back in EM, select component, and then select create EM model and symbol, and then you select OK, and that was successful. So that's done. Select OK. So now you want to create a test bench. So we're gonna go back here. It's test 4, so we're gonna call a schematic test for test bench, and then you want to make sure you select the template. Somewhere in the first quarter of the page you have S parameters. You select OK, and then you got your S parameters. You also want to put a parameterization, so you want to select simulations. In the palette you want to select simulations S parameters, then you want to select parameter sweep, and then you're done. Now, how to get the component in here? As said before in class, as Professor Amaya showed us, you select the component, you call it's, for example, test 4, you just drag and drop. There you go. Look at that, it even has the right color, which is nice. You connect it at one terminal, you connect it at the other. Now there's a bit of difference between like the parameters that we are using for like a component which is made straight from polygon, or like versus like an existing symbol, for example, like the CPW. So that's one thing important to keep note of, is how you do it. Also, the units are very important as well, because if you don't put the units once you put the parameter in, like we call it L, for example, uppercase L, what you're gonna have is a lot of noise, and like it won't make sense what the simulation comes out as. So now we have to create a variable matching that value that we put in, uppercase L. It can be any value, doesn't matter, because we're going to specify what it's going to be in the parameter sweep. We're going to select the value uppercase L. We'll start with 2 because that's the smallest it's going to start from, and we'll go to maybe, let's say 40 for example, and maybe in steps of 5. So we got 9 steps total. Should be fast because it's a small size, so select OK. Also remember, in simulations, my apologies, you should select the module that you want to simulate, which is SP1. Select OK. That's done, and then ready to simulate, so you save and simulate, and now it's going to do its simulation. It gives a warning, which is fine. Oh, look, it's done step 1, done step 2, then step 3. Usually larger sizes like 50 microns or more will take longer, and if you did it in like 200 microns or larger, it's like an hour. And once it's done simulating, you'll get your S parameters. For example, I did a 50 by 200. You can see it has its attenuation with frequency, which is nice, and it also is increasing as the size gets larger. This is a bit weird, actually. It's going in the other direction. Okay, my apologies. Yeah, this makes sense. So you got 2, 7, 12, 17, 22. So as you increase the size, it gets more attenuated. And yeah, that seems fair. So yeah, that's how you basically do a code simulation with parameters for like a component that's made out of polygon. So thanks for your time and have a good day. By the way, I'm busy just as you guys. If anyone else can make a video or show up what else they've done to improve upon the assignment, please post it so we can all benefit from it. Okay, thank you. Take care.